Right? So we want to estimate the natural log of 1.6. So we need a function. So f of x is going to be natural log of x. We need a value close to 1.6 that we can take the natural log of. So we can take the natural log of 1, my garbage can down, and we can also take the natural log of things like e. So 1 is zero point 0.6 away, e is like 1.18, so 1 would be a better value of a. So let's make a equal to 1. We also know that we're going to need a derivative, right? So the derivative of natural log is 1 over x, and our value of x that we're using is 1.6. All right, so if we set up our linearization formula, all right, so we know that f of x is approximately equal to the linearization of x. The linearization of x is exactly equal to f of a plus f prime of a times x minus a. If we plug in the stuff that we know, right, so f of x, right, natural log of 1.6 is approximately equal to the linearization of 1.6. Again, the value of 1.6 on this line over there. Right, so that's going to be f of a. So we're going to get the natural log of 1 plus f prime, right? So that's going to be 1 over 1 times the difference, 1.6 minus 1. So that's going to give us natural log of 1 is 0 plus 1 times 0.6. So the natural log of 1.6 is approximately equal to just 0.6. And this isn't going to be as good an estimate as our previous values just because of like the shape of the natural log. Um, but natural log of 1.6 gives us that. So again, not a great estimate, just because of actually because of, you guys see this in one of the expressions, right? So it's because of the slope of like the natural log. When we look at, you're getting all this like free math in these videos, lucky you. Right, so when you look at this natural log and we look at this point, 1.6 natural log of 1.6. So at that point right there, you can see that this like slope, right, the slope of this line, right, it's not really staying that close. Our value of 1 is kind of far away from it. So this slope is kind of coming up higher than it would normally be. It wouldn't be any better if we used E, but just sometimes, and again, as we'll explore in some later questions, right, so how the shape of the curve, like how quick our derivative is, can kind of affect how good of our linearization is.